What's up guys, Ian Sandusky from Let's Machine back here again for Practical Machinist. Today on Shop Talk, we're going to be going through the average day in the life for a machinist. Before we do, make sure you like and subscribe to see more videos. Let's get into it. Okay guys, so this video today is going to be for some of you guys who are considering getting into the trade or don't know a lot about being a machinist. You know, if you have been a machinist for 10 years, this video is probably not going to tell you anything you don't already know. But if you're someone who is considering either changing trades to get into machining or, you know, this kind of precision trade, or maybe you're in high school and you're trying to figure out what to do once you're done and graduated, this is just going to guide you through some of the things that a machinist does in an average day so you can see if it's going to be something that's for you or not. Let's take a look. Alright guys, so one of the first things you might do when you come into the shop after you've gotten the coffee out of the way is material prep. What material prep is getting material ready to be run inside a machine. So you may use something like this. This is a rolling bandsaw. And what this does is you take material, you mark where you want to cut it, roll the blade in, and it cuts your material to length. Because very rarely do you get material either pre-cut coming in the door to the length you need, or do you need to turn or machine an entire length at once. So the first step is going through and cutting all your pieces of material to get them ready to go. Not too hard, but it's something that somebody needs to do. In some shops, that is someone's entire job, is being a saw guy. Typically that's a job where guys will start out because it's something that is fairly repetitive and a good foot in the door for machining. So that's the first thing I would probably do in a day, is cut my material and get it ready to go. The next thing you might do is deburr and get your material ready to go. Now deburring basically means to remove the burr. When you cut something on a saw, typically it'll have a sharp edge and usually a burr, which is kind of like a piece of material that's left over, and it's usually sharp, ugly, and you want to get rid of it. Also, typically because of that burr, if you try to put that in a vise right away, it's not going to fit right. It's not going to sit flat. You know, you're not going to be able to use a good hard stop on that because it might be kicked out. So the next thing we do is deburr parts. You also have to deburr parts when they come out of the machine, unless you have done a lot of deburring in the machine, but that's another story for another day. Typically, this is something you can do while a machine is running. Some big shops even have entire deburring departments where all those guys do all day is go through and deburr parts. To deburr parts, you might be using something like a belt sander, you might be using a hand file, you might be using a deburring tool, which is kind of a little hooked blade that you drag along the edge. And you know, you could use something as big as a grinder, like a full out bench grinder or a Dremel or a Dumore. All these things are really important to know how to use when you're a machinist in order to make your part fit and finish properly. So this is probably the next kind of thing we'd end up doing in a day. Next up would be setup and fixturing. And if this sounds a little echoey right now, that's because you're inside my machine. For setup and fixturing, this involves setting up vices, work holding, you know, custom fixturing if we need to do it inside the machine and getting it ready to go. Every job has a slightly different setup. You know, something like a standard vise can run a lot of jobs, but the way you set up your tools, the way you set up you know, where things are on the table, whether you have a multi-vise setup, all varies depending on the job. And this as well, in some shops, is someone's entire job, is to set up machines all day so that operators can run them. There's two kinds of machinists in some shops, where you have your operators that basically stand and run the machines all day, and then you have the setup guys. And the setup guys go through and actually set every job up, run the first off and test things to make sure everything's running smoothly. So getting everything together inside the machines You know, cleaning off the table, making sure you're ready to go, touching off your tools. That's kind of the next part that you would get to in a day if you were taking a job from scratch. Next up is, of course, programming. Programming is one of the biggest things you can learn and teach yourself, or at least start to teach yourself, that if you're getting into machining, will help you in your career. Very few long-term machinists, unless you are in a strictly manual shop, and I don't think many of them exist these days comparatively to, you know, 20 years ago, is learning how to program. Programming is taking your drawings of your part, you know, maybe they're 3D models, and putting them into something like this, a CAD CAM system that lets you basically program what your CNC machine is going to do. So for instance, I could program a lathe on here, I could program a wire EDM, I could program a, you know, 4-axis mill, 3-axis mill, 5-axis mill. It's taking information from the drawing, adding tool paths, and basically telling the CNC what you want it to do, and at the end, what that part is going to look like. It is one of the parts of this job with one of the largest learning curves, because it's something that seems simple, but there are a lot of little variables that go into it that really you can only learn by repetition and by trial and error. So learning how to program is going to be extremely beneficial for your career. This can sometimes be guys' entire jobs. There are big shops where all guys do is program all day. You know, if you're into computers, if you're into you know, something that's a little less on the floor, a little less hands-on, programming is an incredible skill to have. Programmers tend to get paid well, but pretty much every machinist, in my opinion, should know how to program, even if they're going to be on the floor most of the time, because being able to take a drawing and a piece of material, put it in your mill, and make a part is something that no one can ever take away from you, and that's a skill you can carry with you your entire life. Which brings us to, of course, operation. Operator is kind of a dirty word for some reason in machinist heads, because it implies someone who stands in a machine and runs it all day. But this is really where the money gets made. You don't sell programs to companies. You don't sell, I mean you can, but you don't make money off your drawings. You don't make money off your programming. You make money off a spindle turning and this machine going, that green light on. This is where the rubber meets the road of machining. And as an operator or as a machinist doing operator work, this is where, you know, chips fly. This is where the machining happens. This is where, you know, the entire rest of your day sets up to doing this. This is typically what a lot of machinists will do most of the day. You know, you spend a couple hours setting up a job, programming it, and then you might be running that machine, or someone else will be running that machine for hours. Operator is a job on its own. It is a very good entry-level position. You know, some people call them button pushers, but essentially it's the person who stands at the machine, runs it, and is responsible for making sure the parts are coming out correctly. Typically, when you're doing operation, you will be doing some QC, so using something like a caliper, like this, to measure things out and make sure that the part is coming out according to the drawing. But generally, you will not be doing the more intensive QC or quality assurance work here at the machine. This is also where you're gonna have to do things like change tools, because tools break. No matter what you want to do, tools are gonna break. Knowing how to change tools, knowing how to touch off tools to read their heights, knowing how to check to make sure the machine is still, you know, the vise is still aligned on the table. All these things are gonna separate a good operator or someone who's good at operating from someone who literally just pushes a button all day. So it is a very, very important part of your day, because a lot of days it may be your entire day. And of course, cleaning, sweeping up all those chips you just made, wiping down machines, cleaning out tables, swiping chips out of the machine. Cleaning is an inevitable part of machining. It's a lot like how guys get into brewing beer because, oh, I want to be a brewer, and then find out that it's 60% cleaning. This job is not 60% cleaning, but unless you are the top of the totem pole and your time is just too valuable to be doing cleaning, you're gonna be cleaning. you know what? It's not a bad thing. Everybody likes having a clean shop. You will clean between cycles. You will end up cleaning at the end of the day. You will clean up your work area when a job is done. You'll have to clean things before you start because that's just the way life is sometimes. Cleaning is a very big part of machining. Unless you are a guy who literally programs all day, in which case you probably just keep your desk clean, okay? After that part is done, the next part of your day will typically be QA or QC, quality assurance or quality checks. This is where you'll take your part to a place like this. Some places in some shops, this place is huge. It is an entire room. In some big shops, there is an entire QA or QC department. At a small shop like mine, we just have a QA or QC area. This is where you use something like a height gauge or your micrometers, the real precision parts of measure, or precision tools when it comes to measuring, to make sure that your part is in tolerance and the part you just made on your machines is actually to the drawing. Machining is a precision trade. Generally, you're not doing things you're not going to check. Very rarely will you have a job where it will say, put 4 holes in a piece of metal, I don't care where they are. Even the loosest tolerances in dimensions are still tolerances. So going and checking, especially the really tight tolerances where something may be plus or minus 1 thou or half a thou or 2/10, with a piece of equipment that is capable of actually accurately and repeatedly reading that kind of information is going to be a big part of your day if you are a general machinist. Some jobs you have to measure every single part because there's a lot of things that are critical. Other jobs you may measure a first off, a couple during the run, and just a final part. It really depends on your shop, whether you are something like 9001, whatever that certification is, certified. Whether you're doing something like aerospace where literally you're going to make a plane drop out of the sky if you are not doing things correctly. But making sure that you are checking your work is going to be a big part of your day. If you get into somewhere like a QA department, all you may do is check other people's work all day, and that's okay. Some guys love it. This is a very detail-oriented part of your job. This is going to eat a lot of time because it takes a lot of time to do inspection on parts and first article inspection and all that good stuff. But it's extremely rewarding at the end of the day when you go through all the stuff we just did, come out with a part that looks difficult, is difficult, has tight tolerances, you go check it, and you are bang on the money everywhere. After this, then it gets shipped out. And shipping out really depends on your shop, guys. I'm not gonna go show you some cardboard boxes and tape because I figure pretty much everybody has put things in a box before. Anyways, guys, I hope this has been helpful. I hope this little walkthrough being a machinist has been interesting for some of you guys who have not done machining whatsoever, or some of you guys maybe just considering getting into the trade. In any case, I think there's always room for more machinists. As with any trade, the more you know, the better it's going to be for you and the easier you're going to be able to find work as a machinist. So never stop trying to learn and improving what you do, okay? Thank you very much for watching, guys. You take care.
And I could see that there was people that didn't like change, masters of our trade. And as things progressed and as new things came available, I was very hungry to learn those things. And I was fortunate to be in an environment to learn. Hello, welcome to Zero Tolerance, located in Clinton Township, Michigan. My name is Steve Michon. I'm the owner, and we started this company in 2011. And we do everything here in-house from part design, mold design, product development, all the way to end result of consumer products. And we're going to walk you through a day of all the things that are involved in doing that. So here at Zero Tolerance, we design and build injection molds. Our services are sinker EDM burning, mold design, 5-axis machining, injection molding, 3D printing, CNC programming and fixturing, spotting and benching, and we also have fast hole and wire EDM. One of the neatest things recently that we've been working on is a shift lever for Ford. It is an overmolded steel rod on a nylon-based plastic. So we've designed and built the mold. Some of the interesting parts about building molds is the intricacy of how they work. When you think of a mold, most people see two halves come together and then the part comes out. Well, internally, when you have undercuts or features that can't be pulled out in a certain direction. But there's a lot of mechanics and engineering that goes into that design, and we do that here. What differentiates Zero Tolerance from other shops is our ability to make changes on the fly. We're very versatile. We learn the new softwares. We try to implement everything we can. So we're taking advantage of software, tools, and fixturing to be more competitive, provide better pricing for our customers, better lead times, and trying to gain more profit as we grow. Our fixturing is really key to what we do here. Most people are familiar with Aroa and 3R type fixturing, and we utilize those along with, we sell aftermarkets using Sunspot tooling, and we take advantage of everything that they're capable of. Well, here we're at the wire EDM machine. So what happens with this machine is it utilizes a 10,000 brass wire, and it controls an electric voltage specific for different thicknesses of material to wire or to EDM or electronically displace the metal in a certain path, as you can see on the screen here. And it will make very precision cuts using electricity. And it's a submerged tank, so it's underwater. It's dielectric fluid is what it's called, so it's basically deionized water. This gives us a huge advantage for making very accurate parts with very little effort. Part of the advantage that we utilize Sunspot for is the fixturing and holding of our workpiece, where it's a modular system, and we can take it on and off with very little effort and extreme accuracy. So using it's a 3R style holder, we're able to do a lot of different fixtures and setups quickly and easily and repeatedly. So I highly recommend these types of fixtures for everybody's shop. They work well, and we utilize both Aroa and 3R. They're in a lot of shops that way now today, but the Sunspot's aftermarket version is just as good, and we've been using it for years. All right, I'm going to dive into one of the molds that we had here that's a pretty good challenge for us, in which we do accelerate at. We have a 2-cavity tool. It is the same hand. It's not a right and left. It's got 2 hydraulic cylinders that drive 2 of the slides, and it has a certain pattern of closing that has to happen in order to create all the features on the part. This particular part is an interesting one. It's a handgun, and it's got a lot of internal action to it. Our design in the CAD allows us to prove out all of our thoughts before we put them into steel, allowing us to put slide details where they can go, make the design robust, and give the parts nice clean shutoffs. It's well designed. We've got a lot of experience in designing and a history of building really nice molds. This particular part has a very interesting gate. The injection point where the plastic enters the part had to be in a specific spot that the customer requested, and it was a challenge to get it in that spot. And we were able to achieve that. It's a valve gated hot manifold, and you cannot physically see where that is happening on this part, and the customer is very happy about that. All right, we are now at our 5-axis machine, our Makino. Makino is known for very high accuracy, and our name is Zero Tolerance, so we try and shoot for zero on most of our tooling. We've leaned on a lot of our skill as tool makers to overcome tolerance issues in the past with older machines, and with the newer machines we're able to hit numbers like we've never have before. And now with 5-axis in our shop, we're able to do a lot more work with many saved hours with setups and times. Here's one of the items we've done on this machine. It is hand loads that don't have any true square edges on them, and these were programmed and machined here using the Sunspot tools, Cimatron, and the 5-axis Makino. And we will use our wire EDM to slice these parts off of this holder, and it'll give us a part that's 100% done for the prototype mold. So as you can see behind me, I'm machining the last piece of a hand load for a mold that we're going to be finishing up here next week. It's making a complicated part starting from a raw block like so, and in one setup we're going to be able to get all of the details machined onto that block. Here we're at our Eagle EDM burning a part shape into a cavity block for a Ford F-Series component for the steering column. We have our electrode, very small details, putting these features into the steel using EDM technology. Using this new technology, we went from making 3 electrodes, which takes more time when you CNC them, to we can get down to 1 electrode, which burns faster, we can cut it faster, and it's extremely efficient for us. Okay, here we have our electrode cutting CNC. The way we cut electrodes is designed to increase our throughput, efficiency, and accuracy. What we do is we group multi-stations together and a whole library of tools. This allows programming to be simplified, setup to be simplified, and the whole process then is much quicker and more efficient with less errors, allowing our customers to have a better benefit for complex geometry and the end result. Here's our 3D printer. It's a Mark Forge. Came to us through a diamond project to be part of a network of 3D printers across Michigan. We're using it in our shop for prototyping, fixturing, and actual useful tools. It's an industrial grade printer that uses a plastic material mixed with, it's called onyx. It has a carbon fiber base to it, so it's extremely strong. And we've been able to utilize it for proving out concepts for the shop, improving our injection molding process. What I like about having this printer here is the ability to take an idea, draw it really quickly, and have it print and have it the next day. I can literally test components, test fixturing, test the tools out before we spend a lot of time on it. So it's very useful in the shop. It's hard to get that mindset of being able to do and utilize a new tool like this because it's new. Most people don't like to change. We like to change around here, so we're always looking to make something better. We came up with a fixture or a loading system. Instead of end-of-arm tooling, we do it manually. We were able to iterate different styles of fingers, and we came up with a tool that we use every day for loading 8 inserts into an injection mold. Now we're at our molding press, where we've developed our claw, we call it, for loading inserts through the Diamond Project and Automation Alley. We have become way more efficient with this tool. Initially, it was designed simply to insert these parts, all 8 of them at one time, but we found out there's a lot more benefits to it. It's a safety feature. The tool's running 275 degrees, so the operator is safer. It also gives the operator something to do while the machine is in process, so there is very little wasted time, and our customers have been in trouble with timing on multiple occasions, and we've been able to solve that problem for them and for us in the process. We came up with the idea for an end-of-arm tooling for putting a real robot in place for this project. The budgets weren't going to work out for that. It was going to be over $100,000. We were looking at doing we had it actually all designed in CAD, and we ended up finding a way to make it handheld to start off, and if the project continues, then we could invest in the future and buy a robot eventually. But in the meantime, we were looking to increase our productivity, make this more efficient, and have a more consistent cycle when you're molding. And this 3D printer and our design team allowed that to happen here. The biggest thing I see with all the technology that there is, zero tolerance, is the people that are here make zero tolerance what it is. I feel that we are going to be focusing on making an environment to bring in new people into the industry of manufacturing. I've seen a lot of it go away, and our mission here is to bring it back. When I got started in this trade, I was learning from someone, a master, had 30 years experience. I was a young kid, and I could see that there was people that didn't like change, masters of our trade. And as things progressed and as new things came available, I was very hungry to learn those things. And I was fortunate to be in an environment to learn. One of the good things about the social media is the community that is out there. The machine shop world, machining and EDM and mold making. This industry is a small group of people, highly skilled, and it is interesting that the problems you're having, someone else is having those too, and there's a lot of solutions out there. And if the borders are down and people can share, this country can grow, and our industry continues to get better. Our company has been posting our media for quite a while, probably 4 or 5 years now, and the reason that we're even on this video today is for Practical Machinists saw something that we had posted, and they shared it, and it just becomes a part of the larger community, and it's a benefit to many shops. I started off really small, living in the basement of my parents' house, and ended up buying a machine for my tax return. And I took like 3 months to rebuild it, and it was a Fidel. Everybody knows what a Fidel is. We got it working, and I started my shop, wrote down a bunch of goals, and 10 years later I've pretty much achieved those goals with new ones as I go. So there's a lot of opportunity today, more than you think. You can find Zero Tolerance on LinkedIn, Instagram, Facebook, and those are our social media outlets. And also our website, obviously. Social media seems to be a very powerful tool from what we've found. We have posted our work and more information about what we do, and we've seen a lot of traction from it. It's a very powerful tool. Everyone's looking at their phones today, and I think that it's overlooked as a way to grow your business. I just want to wrap up our walkthrough today and talk about really the most important part about our whole company, and that's the people that are here. The team that we built, how much they care. It's about relationships with our team and with our customers. Without that relationship and the people, there's really no company. It's not me, it's them, and we're blessed and highly favored, I'll tell you that, and God bless America.